All right, class, welcome back to another lesson. My name is Mr. Holbert, and I will be your teacher for today. Today, it is all about fractions. Fractions are one of the most hated topics in math, but hopefully by the end of this video, you'll have a little bit more confidence with them, and you'll be ready to tackle that next fraction assignment. Before we get into how to add, subtract, divide, or multiply fractions, let's talk about some general things. For example, what is a fraction? For the record, a fraction, and we're going to use 1/2 over here as an example, classic fraction, right? Fraction is the same thing as division. So 1/2 is the same thing as 1 divided by 2. These are the exact same thing. This is just a different notation of 1 divided by 2. So, if that's the case, why do we use fractions at all? There tends to be two reasons why, one of two reasons. The first reason is if we divide something, in this case 1/2, or 1 divided by 2, and if it is less than 1. 1 divided by 2 is 0.5, and that is less than 1. If it's less than 1, we tend to keep it in fraction form, or we could convert it to a decimal. The second reason why we'll use fractions is if we are dividing two numbers from each other, for example, 3 divided by 2, you'll notice that the answer isn't a whole number. In this case, it is 1.5. So 1 and then 1/2. And this is the other time we tend to use fractions. When the answer isn't a whole number, it's not pretty. So we use that notation in those two circumstances. But it is still the same thing as division. Same thing. Now, another important thing that I would like you guys to keep in mind as we watch this video is that a fraction is the same thing as a decimal, which is also the same thing as percentages. These three things all represent the same amount, the same number, just with different notation. So we can convert a fraction to a decimal to a percentage, or we can do any jump between these that we want. And there's one more thing that a fraction is the same thing as, and that is ratios. Usually written like this. A ratio is just a fraction. This ratio represents 1 for every 2. You might see this in things like cooking or sometimes some word problems, but ratios, fractions, same thing. Fractions, decimals, same thing, different notations. Fractions and percentages, same thing, once again, different notation. Okay, now besides that, let's come over here. And once again, we're working with 1/2. And here's something that I would like you guys to keep in mind is that the bottom of the fraction has a name. It is called the denominator. And the top of the fraction is called the numerator. So keep this notation in mind. The top is the numerator and the bottom is the denominator. I will be using this notation throughout the video. The reason why is that, first off, it is good to know math vocab. Second, you will see this on a test or a problem, and hopefully I can build up your confidence a little bit with which one's the numerator, which one's the denominator. Before we get started, there is one last thing I would like to talk about. Let's say that we have the number 3. Seems like a good number, right? All numbers are secretly fractions. How we can change this into a fraction is by simply dividing it by 1. This looks like a fraction, doesn't it? It kind of follows the same general trend as that one over there, but instead it's 3 divided by 1. Anything divided by 1 is itself. So we don't normally write this 1 underneath because, well, it's the same thing as just writing 3. But this idea is important to keep in mind, as sometimes you need to be working with a fraction And anytime you need a fraction, you can take a number and put 1 underneath it, and it becomes 1. Okay, to start off, we're going to be starting with how to add 2 fractions together. So let's move on to that first problem. Okay, we're moving on to our first problem. Here we have 3/2 plus 6/5. So we want to add these 2 fractions together. So before we even get started on trying to add them, what we need to do is we need to make sure that the denominator, the number on the bottom, is the same. We can't add 2 fractions together unless they have the same denominator. Now, how am I going to do that? Well, first off, what we need to find is the LCM, the least common multiple, which I have written over here. What I mean by that is we need to find the smallest number that this number multiplies into and this number multiplies into. So there's a couple of ways we can go about that. We can start kind of guessing numbers. For example, I could guess 6. Let's see. 2 does multiply into 6. 2 times 3 equals 6, right? 5 doesn't really have anything that it can multiply to get to 6. How about 7? No, 2 doesn't multiply into 7, and neither does 5. 8 works for 2 but doesn't work for 5. 9 doesn't work for either of them. So how about 10? Well, let's see. 2 times 5 equals 10, and 5 times 2 equals 10. So we found a multiple for both of them, and it happens to be the LCM, the least common multiple. So underneath here, I'm going to write 2 new fractions, and we want the bottom for both of them to be 10, because that is the least common multiple. Another way that you can find a multiple for both the denominators is if you multiply them together. So if I did 2 times 5, in this case, I would get 10. Now, for this example, when we multiplied our denominators together to find a multiple for them, it also happened to be the LCM. That will not always be the case. We just happened to look out this time and it happened to work out, but this way does guarantee at least you find a multiple. And as long as you find a multiple to have for the denominator, it'll work out for you. Okay, now let's come back down here. We have our 2 10s in the denominators. We're going to add them together. Now, how did I go from 2 to 10? I can't just say that I did it, right? I need some logic behind it. And that logic is going to be that I took this 2 and I multiplied it by 5. Now, if I leave this how it is and I write a 3 on top, I'm going to end up messing up our ratio. I'm going to mess up our fraction and change it to something completely different. So if I multiply the bottom by 5, I also need to multiply the top by 5. So 3 times 5 is 15, so I get 15 down here. 15 over 10 is what we end up with. Now if we come over to our next fraction, how do I go from 5 to 10? Once again, I can't just say that I just went there. I have to have some logic to back it up. And that logic is going to be that I took this 5 and I multiplied it by 2. 5 times 2 is 10. And if I did it to the bottom part of my fraction, I have to do it to the top as well. 6 times 2 is 12. So the top over here is 12. Now that I have gotten to this point, my denominators are the same, I can add my fractions together. And here's how we are going to add them. We're going to go straight across for the numerator, the top number. And we're just going to add them normally. So 15 plus 12 is 27. The bottom is where things get a little bit weird. We're not going to change it at all. It's going to just stay 10. We're going to leave it how it is. So then we end up with a final answer of 27 tenths. That is our final answer for this one. Now, before I move on to how to subtract 2 fractions from one another, one thing I want to talk about is how did we go from this to this? I know I kind of talked about multiplying both of them by 5 to get to our least common multiple for the bottom, but why is that allowed? How is that even remotely allowed? And let's go back to our original fraction of 3/2 up here. I'm going to convert that to a decimal for you real quick. 3 divided by 2 is the same thing as 1.5. So that's our decimal. And if we look at our new fraction that we get after multiplying the top and the bottom by 5, we get 15 over 10, which if I take a minute again for you and convert that to a decimal, I get 1.5 again. So if we simplify these down, they're actually the same fraction still. They have the same ratio. It's just that we manipulated it a little bit. And by multiplying the top and the bottom by the same thing, we keep that ratio. And since we keep the ratio, it's actually the same fraction. So watch out. Make sure that you guys multiply both the top and the bottom by the same number. Okay, let's move on to subtracting two fractions from one another. Okay, let's move on to our next problem. If we look over here, we have 6/5 minus 10/3. Two fractions being subtracted from one another, and thankfully, a lot of our skills from adding two fractions together will translate over here. So once again, with these two fractions, when we are subtracting them from one another, our first step is to get the denominators to be the same. And to do that, we need to find a multiple of some kind. The LCM would work best, and this is another instance where if I multiply the bottoms by one another, so 5 times 3, I get 15. Once again, that is a way to guarantee that you find a multiple for both of them. And once again, in this case, it happens to be the LCM. So I'm going to come down here and I'm going to write 15 and minus 15, because we need both of the denominators to be 15. Okay, and once again, we cannot just say that I changed it to 15. We need some logic behind it. How do I go from 5 to 15? And how I do that is by multiplying it by 3. And if I multiply the bottom by 3, I have to multiply the top by 3. So I do 6 times 3, which gives me 18. Come over here. How do I go from 3 to 15? Well, I multiply by 5. And if I do it to the bottom, I have to do it to the top as well. So then 10 times 5 is 50. Okay. Now, when we have the same denominator for two fractions and we're subtracting them, we subtract straight across. For the numerator, we subtract straight across. So we do 18 minus 50, which gives us negative 32. And then for the bottom, just like when we added, we're actually going to keep it the same. We're not going to alter it whatsoever. So it's negative 32 over 15. And that is our answer right there. Okay. So that is how we subtract two fractions from one another. Keep the LCM idea in mind, and remember that you have to have the same denominators before you subtract them from one another. Same strategy as when you're adding two fractions, except instead we're subtracting here. Okay, next we're going to go over how to multiply two fractions together. Okay, here we are on our next problem. We're going to be multiplying two fractions by one another. And if you look here, I actually have two separate problems. And the reason for that is multiplying two fractions together is thankfully very straightforward. So let's start with this one over here. We have 4/5 times 2/12. And how you are going to multiply two fractions together is you are going to multiply straight across. So I'll do 4 times 2, that goes on top. And then I'll do 5 times 12, which is 60, and that goes on bottom, and that's it. Yep, that's all. When multiplying two fractions together, you just go straight across. I have a lot of students who struggle with this because they think that it has to be some insane thing. Since it's a fraction, it has to be complicated, right? Nope, thankfully with multiplication, we just go straight across, and that's it. However, there is an issue with this one. And that is that this is not our final answer. The reason why is that we can simplify this fraction. Class, make sure that you simplify your fractions. Teachers will mark you wrong. There might be other issues. Make sure you simplify them. And how I know that I can simplify this fraction is, well, the top number is a positive number, and the bottom number is also positive. And if both of them are positive, that means that both of them can be divided by 2. So we can simplify by doing 8 divided by 2, which is 4, and 60 divided by 2, which is 30. Anytime that you have a fraction, you should check if you can simplify it. My suggestion for checking is you should look at the top and the bottom, and you should just start seeing if both of them can be divided by the same number. I would start with 2, and I would work all the way up to at least 9 to check those. So I'd be like, okay, 8 and 60 can be divided both by 2, which we did. How about 3? 3 doesn't go into 8, so 3 doesn't work. We can't simplify that way. 4 also goes into 8 and 60, so we could have divided this by 4 instead. Okay, let's move on to 5. 5 works for 60, but not for 8. 6, once again, works for 60, but not for 8. 7, neither of them are divisible by 7, so that doesn't work. 8 works for the top, but not the bottom. And 9 doesn't work for either of them either. So we get to this point here, 4 and 30. And I suggest that you check again, even after you simplify that first time. Because if we look here, we have 4 divided by 30. Remember what I said a second ago? Both the numbers, the top and the bottom, are positive, so that means that both of them can be divided by 2. So we could simplify even more, which that simplifies to 2 over 15, and this one is our final answer. If we ran through and we checked all the different numbers, we would find that there is no number that divides both 2 and 15. So, now that we have this one out of the way, let's do a second one. We got time. So once again, we're going to multiply straight across. So I do 2 times 4, which gives us 8 for the top. 3 times 5, which gives us 15. 8 over 15. And we can start doing the test where we check 2. 2 works for top, but not the bottom. 3 works for bottom, but not the top. 4 works for the top, but not the bottom. 5 works for the bottom, but not the top. So on and so forth. This one is actually our final answer. This one cannot be simplified any further. But make sure that you guys simplify your fractions, otherwise you could get in trouble with your teachers. Okay, so one last time to reiterate. When multiplying 2 fractions together, you multiply straight across. So the top times the top, the bottom times the bottom, write it as a fraction, and check if you can simplify. Okay, now let's go over how to divide 2 fractions from one another. Okay, so now we are on the last problem, and we have 4/5 divided by 3/2. And if you look, I wrote it twice. Unfortunately, we're done with the super easy stuff, how multiplication was, but we actually have 2 different methods on how to divide fractions from one another. And I'm going to show you both of them, and you can decide which one you prefer. So let's start with this one over here. This one is a classic. It is called, what you do is, it's kind of like a mantra that you remember. The first one you say keep, then you point to the sign and you change that, and then for the last fraction, you flip it. You say keep, change, flip. There's a couple other ones that I've heard before, but this is the one that I learned, and I think that it flows together really nicely. So, our first fraction, we're going to keep it. It's perfect how it is. We're going to change our division sign to multiplication. And then we're going to flip our last fraction to 2/3. So you are just going to flip it. And then if you look now, you have 2 fractions, but instead of being divided by one another, they're being multiplied by one another. And we just went over how to do this, where you multiply straight across. So I do 4 times 2, which gives us 8. And I do 5 times 3, which gives us 15. Huh, that looks familiar, doesn't it? So this is our final answer. When it comes to dividing two fractions from one another, you can do the keep, change, flip technique. Once again, just to reiterate it, we keep the first fraction. We change the division sign to multiplication. And then we flip our last fraction. And then from there, we multiply normally, and that'll give us our answer. There is a second way, like I mentioned before, and that is cross-multiplying. Cross multiplication, which a lot of you have heard of, it's also called the butterfly method. We actually use it when we are dividing two fractions from one another. So what cross multiplication is I take the top number here, in this case 4, and I multiply it by the bottom. So I do 4 times 2, which gives us 8. And notice that the 4 is the top number. So I'm going to take this 8 and I'm going to write it on top. Okay. Now, I need the bottom number though. I still need the denominator. And that is where we cross multiply the other way as well. We do 5 times 3. 5 times 3, and we get 15. And since I started with the bottom number and then multiplied to the top, I'm going to write the 15 on the bottom. And if you look here, we got the same answer both times. Another way that you could do the cross multiplying is you could do 4 times 2, 8, 5 times 3, 15, and then if you remember to flip these and write it as such, you'll still get the correct answer. When it comes to the cross multiplying method, I think it's more straightforward. There's no weird trick that you need to remember, but the tricky part of it is remembering which number goes on top and which number goes on bottom. Because if you wrote instead 15 over 8, you would have gotten it wrong, when in reality the answer was 8/15. So a word of caution with this one, make sure that you know which number goes on top and which number goes on bottom. If I had to make a suggestion for which one to really work with, I would say cross multiplying. There's a couple other applications for it that we use it for. Keep, change, flip is pretty much only used for this scenario, but cross multiplication has a couple other uses. But either one you can choose, and they both work. So with that being said, that was our lesson on fractions. I hope that you feel a little bit more confident about it after this. But thank you guys so much for coming to class today, and I hope to see you in a later one. Thank you.